Okay, welcome everybody. Today my presentation is on the methodology for electrical substation maintenance programs. So it's divided in two parts. Why have maintenance programs for high voltage substations, and what are the part two, what are the different types of maintenance strategy? So this is the topic for today. So the reason I have made this presentation is that during my various travels across the world, I visited multiple utilities and could compare their practices. And I noticed that most maintenance teams copy the maintenance operations of other reputed utilities without analyzing them to see if they fit to their own needs. And for example, they will buy some instruments thinking that the instruments will do their maintenance. And what I say is serious. So part one is divided into three sections. Why a maintenance program, the methodology, and 4 steps to respect. So why develop a substation maintenance program? To reduce risk of failure, to protect worker safety, collect data, and support decisions. So here you have the flow chart, which describes the steps that you need to respect if to have a good methodology for a maintenance program. So if you see, the first step is the inventory. So you have pictures of transformers, breakers, reclosers, etc. Step 2, it's observation and testing. So which is divided in 3 sections. First, it's we need the information on breaker transformers. Then we need information on inspection and testing. Then also the monitoring, all the monitoring systems give also good information. The step 3 is the analysis and data processing. And thanks to this information, so we can go to the next step, which is the intervention and planning intervention. So we need to do planning. We need to do some actions to be able to repair or refurbish. And all this information must be plain, because a lot of teams are involved in this process. Yes, I need to have, okay. So the 4 steps: inventory, observation and testing, analysis, intervention. So step 1 is the inventory. So here you can see a nomenclature used by Hydro-Québec. For example, 1D for circuit breakers, 1M for measure transformer. And so this helps when you have just a simple line for the name of a file, so you can see immediately that it's a breaker or it's a transformer. Here you have some fields that are necessary to build your database. So you notice the device attributes, for example, the manufacturer date. So this information, you can find it on the equipment's nameplate, and the first use, the warranty, etc. So device specifications like the exploitation number, some codes, utilization code. So it gives the information that if the apparatus is available, and their evaluation, in reserve, in repair, in service, out of service, etc. You have, of course, the manufacturer, the serial number. Also, you need to put some specific characteristics as nominal voltage, nominal current, etc. And of course, the location, and the initial commission testing is very important, because These reports are used each time that you do a test, like a periodic test. You need absolutely to compare it to the initial testing. Here you have an example of breakers database where you can see the type of the breaker, the manufacturer, serial number, the technology. It's good to have also because this way for air blast, you can see immediately that it's a very old breakers, the year of the installation, the location, etc. The step 2 is the observation and testing. This observation is testing is divided in 3 sections also. Like, of course, the information on the apparatus that you have taken from the first step, which is the list of your inventory. Second, after is the inspection and testing. So we means by inspection, and you have some periodicity testing. So this information must be recorded, and also the monitoring, which is recorded from monitoring systems. So this is like the first section, the information from the inventory, device attribute, device specifications, etc. So all this information comes from step 1. Because if you need to do testing, you need to do what you are going to test. The step 2 is here you can see an example of inspection and periodicity table for breakers and all the actions to be repeated on periodic basis. Here you can see the different type. You have 4 types of inspection: the routine inspection, limited inspections, provisional inspection, and the complete inspection. And if you can notice the periodicity on the right, for example, the routine is done each year, the limited each 4 years, the provisional inspection 8 years, and complete inspections here is just to show that sometimes the periodicity is based on a number of operations instead of time. And if you notice also the routine inspection is you have a list of actions to do. And if you can see the limited inspection, you can see that in addition to routine inspections, we add some actions. Provisional, so you do what you have done in the limited inspection, and the complete inspections include all what you do in the 3 other inspections. Here you have an examples of tests for breakers linked to international standards. If you see, for example, the first line, you have the contact timing test, which means that you need to measure the contact resistance of the testing, and it's a mechanical and it's linked to a standard. Some of these tests are mandatory. If the standard, the international standards specify that it's needed, and other tests are recommended because the experience can tell you that this test is a good test because it gives you a good indication on the assessment on the of your breaker or your transformers. Step 3 is the analysis and data processing. So all the tests are organized in a database, and of course you need to put the first test, the inspections, the results, the repair interventions, and some information which help you to analyze and determine the type or urgency of maintenance interventions. So the analysis, these teams will when you record all this information, so you have the responsibility to reach a verdict, which is based on the analysis. And then after, thanks to this information, you can determine what kind of actions and priority you have to do on your apparatus. Here you have an example of collected database for breakers. Here it's you have the type of the breaker, what kind of tests you have done, and where you find the reports for this. For example, the first line for the contact timing test, you are going to find the results under pole 433. And also it indicates which who has done the test. Intervention. So this is planning of intervention for repair or refurbishment. So here you organize and you coordinate the inspections. So maintenance personnel can prepare the required maintenance actions. So why? Because a lot of people are involved in this intervention. Of course, you need to involve the purchasing department because you need to buy the parts needed for the repair or the refurbishment. The warehouse is involved also because when you buy these parts, you need to store them somewhere, and so this way the guy can find them for their repair. The maintenance teams are involved because they are going to do the job. They also must be trained. They must be able to do the job. And the operators are involved. This means that if you need to do a repair on the breakers, for example, or transformers, so these breakers will be offline. So you need to redirect all the electricity to the final client. So this way, the final client will not be affected by the interventions. So here we are always in the step 4. You have finally you get a specific database for maintenance intervention, and there the minimum that your database should contain the serial number, the analysis report, some reports coming from the advisories, also the priority level, if it's urgent to do the job or not, the deadline, and the others items also. Here you have an example of advisories for breakers. So you have the report number of the report, the advisory name, the priority if it's in urgent or not, the deadline. So all these informations are required. So this way you can do a good the planification. Example of advisories. So the advisory report that inform the maintenance manager of the necessary work to be performed on each piece of equipment. So it contains at least a list of concerned equipment, list of actions, list of parts, list of special tools, and so on, see. Step 4, it's always planning intervention after an advisory. So once an advisory is issued, intervention planning begins. So you can reveal this full inspection can reveal several critical issues that require actions through similar equipment. And of course, coordination is needed. And also you need to define the task, the parts, the tool, as I told you before, the training, and of course the budget. If you don't have the budget, so you can do nothing. That's it. Intervention. So the post-intervention follow-up. It's when you have finished your job, you record completed the intervention for traceability. It's important. You detect recurring failures that may reveal hidden issues on some brands, some models, and you need use findings to guide replacement of or upgrade strategies. Here you have example on step 4, example of completed intervention. So on the, for example, the first line, you can see the to-do list 1, the teams which is in, which has done the job, the schedule, the start date, end date, and the information on the manager. Conclusion. So this section introduced the fundamentals of building a maintenance program, and the content is based on our experience with Hydro-Quebec's proven approach. And at the end of what you have designed, once your program is in place, the next question is, how effective is your substation maintenance program? So now we are in the part 2. So what are the different types of maintenance strategies? So there is no universal classification for maintenance strategies, and different source defines them differently. And the common approach groups them by level in planning and execution. And based on this, 4 main types are commonly recognized. So here it's first one, reactive maintenance, run to failure. Second, run to fail maintenance, preventive maintenance, predictive maintenance. So reactive maintenance, what is it? It's run to failure. So the maintenance is performed only after equipment failure. And the focus is on quick restoration. And this could be applied for non-critical, low-cost, easily replaceable assets. The risks of this method is the increased downtime, safety issues, and higher long-term costs. It's the kind of things where you decide for your car not to do the maintenance, but to wait that when it will break. So it's not a necessarily good approach. Run to fail maintenance. So maintenance is delayed until the asset fails or reaches end of life. So some planning is in place. So for example, you can prepare some spares, some tools, some procedures ready. So this way, in case of failure, you know exactly what to do. And this always works for low cost, non-critical assets with predictable failures. You know that this part is going to fail, so you just wait that it will fail. The risks, the resource waste, downtime, and lower reliability. So this is the second strategy. The third one is the preventive maintenance. So here you have maintenance is done regularly while the asset is still operational. And the aim is to reduce failure risk and extend service life. You have the 2 types, the time-based, scheduled at fixed intervals, like we have seen in periodicity, like for the 1 year, 4 years, 8 years, and usage-based, so based on operations that we have seen, like on the first, on the previous slides, 1,000 operation, and the risk over maintenance here on this, it's the over maintenance, missed issues, or unnecessary downtime. So this is like what usually I can say the good utilities use is the preventive maintenance. And so now, but we are in 2025, and now each utility is trying to do the predictive maintenance. So what is the predictive maintenance? It's based on the asset's real-time condition and performance. We use sensors, data analysis, and machine learning to detect early signs of failure. This is best for critical high-cost assets with complex failure patterns. And the challenges, of course, is high upfront cost, need for expertise, and reliable data. Here you have an example for predictive maintenance using Vibro-Acoustic diagnostics. So it is considered to be a light test and an effective tool for enabling predictive maintenance of high voltage transformers with tap changers and high voltage breakers. This helps better resource allocation. The maintenance teams can focus on the equipment that needs attention rather than following a rigid calendar-based schedule. And the idea is to improve scheduling and planning. And data-driven insights allow for more accurate maintenance scheduling, optimizing workflow. So here you have, in next slide, an example of action plan to elaborate a predictive maintenance for transformers with OLTC. So as we have seen in the previous slides, you establish your transformer list with a tap changer to monitor or to follow. For each transformer during downtime, you do a complete test. We have developed some checklist to do this offline. After you produce a complete report for each transformer with the OLTC. And according now to diagnostic results, you can establish your maintenance plan for each transformer. And after you do your testing online, and these tests are performed to be compared with the reference we got from the step 2. And if you have a change, if you have no change in your tap changer, so just do nothing. So this way you can extend. If you say that your maintenance plan, the periodicity is based on 8 years. So what you do with this online test, so you see that there is absolutely no change. So you do not touch your tap changer. You do not open it. So this way you can extend, instead of 8 years, you can go to 9 years or 10 years, thanks to this information that you get online. Here you have some examples of checklist, how to get a complete test as a reference for a tap changers. So it's systematic. Here are the kind of reports that we got from the test results and the recommendations report. For example, here in this case, if you can see motor drive current, we have noticed a major difference between the two LTC. So here it's a comparison between two transformer, T1 and T2, that you can see on the bottom. And then, so they have noticed that there is a serious difference between these two transformers, which is exactly the same family, the same tap changer. So with this, so they have to react. So you can plan an intervention thanks to this information. Here you have some examples on the results. Here you can see from tap changer from tap 1 to tap 2, and from tap 2 to 1 must be absolutely the same, because it's exactly the same mechanism. And here you can see quickly that the Vibro-Acoustic gives you an information. You have a lot of impacts. So this means that if you compare these impacts on the left and on the right you have 4 impacts. On the left you have 6 to 8 impacts. So there is something wrong. You have a bad adjustment on your tap changers. And so Zansol is focusing now on Vibro-Acoustic technology. So why? Because it's like a stethoscope for we are able to listen to the transformers exactly like we do with an with a stethoscope. So it could be, what is nice is that this Vibro-Acoustic technology can be used online or offline, and it's very simple to use. On the picture on the right, you can see a transformer with a tap changer. we use one accelerometers, and here on the bottom, the picture of the bottom, you have three accelerometers, phase E, B, and C, and so the timing test is done easily, and it could be done online. So in fact, you have a lot of tests that could be done just in listening the vibroacoustic signal. So you get like a pattern, like a fingerprint. So this way you can use it for a future reference. So it's why we think that this innovation, Zensol, can help utilities to do predictive maintenance. Thank you.
Okay, great. Thanks very much for the presentation. We have some questions, Fouad. First one, what kind of equipment data should we collect during the inventory phase to make future maintenance easier?
Well, I think I have given in step one, like here, you see, here you have some fields that you can record, like the manufacturing date, first use date, warranty, and then next nominal voltage. So all this information is recorded in a database, and then after, so if you want the location or the serial number, you have it immediately.
Okay, next question. How does your vibroacoustic diagnostic method or technology distinguish between mechanical wear and electrical faults in OLTCs and breakers?
Okay, so if I understand the question, the vibroacoustic is the fact you don't have to open your breakers, well, your breakers or your tap changers. You just put an accelerometer on your apertures, and then you listen. So you listen the impacts, and with this and you compare this signal to the motor drive. So, but this is another presentation that you can find in our website.
I think they were asking, how can you tell the difference between mechanical wear and electrical faults?
If you want the electrical faults, you must do your testing online. Because this way you can get arcing. If you do exactly the same test offline, you will not see the arcing of the contacts. So, well, in the other presentation on the vibroacoustic, on the tap changer, we show this clearly in a slide where you compare offline, you get exactly the same vibroacoustic signature, but when it's online, you can see the arcing at a specific point, and it's easy to recognize.
Okay, can you describe the process of establishing a reference signature for vibroacoustic testing?
Okay, so I go to the next, to the last. Yeah, it's here. You see here before testing. So here we have some information that we record, like a nameplate, make on transformer, etc. And then after you do what we call the vibroacoustics, and you take the motor drive current, and after this you get your signature, and here you have a lot of information that we can we have always, I see, go to the next to the video, and you will have a lot of details on how we are able to analyze the signature, the vibroacoustic signature. For example, asynchronism are very quick. Motor current fault are very easy to to find, and it's just a matter of learning the signals and what means each signal, and then how it's recorded in the time, because it's always by time. So the axis is always the time, and during this time you have here, I can show you, for example. No, I think it's at the end. Do you see here?
Yep.
On the left, you have
Yes.
the motor current. The motor current ends here, and here you have the vibroacoustic phase A, B, and C. And here you have the same, but this one's from 1 to 2, and 2, and this one is 2 to 1. And they must be identical. So the impact are different. For example, if I take my two hands and I do like this, so it's going to be synchronized. But if I do this, so immediately I can see that there is some difference in the timing. And here you can record all this when just in zooming the vibroacoustic signal.
Okay. Another couple of questions. How can your sensor improve be applied to motor maintenance? Can it detect partial discharge, bearing disorders, and greasing issues in motors? Interesting question.
Here, look what we record, and here you can see on the bottom the signal. You see it's an EC current, and we use only an EC current clamp or a DC current clamp. We have our interest is not in the DGA, or this is another story.
Yeah.
We focus really on the motor current, because it gives a lot of information when to start, when to stop, and the synchronization between the tap changer, the diverter, how the diverter works according to the motor current. And if it's not synchronized, your tap changer could be in serious problem. So, but
Yeah,
it's not related to the DGA.
as I've mentioned in other forums, maybe half of all transformer failures are tap changer failures, correct?
Yes, exactly.
Yeah. Yeah.
Yeah.
Large amount.
Yeah, a large amount. Yeah.
Yeah.
And it's a mechanical. Yeah.
No, that's right. It's a mechanical issue.
Yeah.
So, how does your company address issues like sensor reliability and data management?
Sensors reliability. So
Yeah.
the
Are the sensors reliable, I guess?
yeah, well,
Do you have issues
in
with sensor reliability?
uh, no, I don't think so.
Okay.
But what is important to know is that we use sensors that like, for example, accelerometers. We don't manufacture them. We buy them from reputed companies, and well, I don't see any issue around this.
Okay.
For the reliability of the data that you record with these sensors, it's easy to recognize if a sensor is not working properly.
Okay, great. Good presentation. I like
Thank
your
you.
I like that new presentation. That's a good one.
Thank you, Randy.
All right, great.